Alrighty folks, we have the controller pretty much completed. So what we're doing today is wiring up the high voltage cabling with some of our nice shiny new previously unobtainium orange traction cable-y stuff obtained from Mr. Kloppenberg. So we're going to go ahead and just do a few run-throughs on how this is going to work out. So what I did also here, had some difficulty identifying these land holes here where the traction cables enter the controller. Now it turns out that this thread is some US standard that would be somewhat difficult for me to and expensive to get a hold of. So being a cheapskate, what I decided to do was I got some standard 25mm plastic glands and epoxied them in place here. So we'll see how well that holds out. What else we got? We've installed a relay that will control the ignition warning lamp on the dash of the car, so that when the pre-charge completes and the controller is enabled, that will extinguish that lamp. We've also gone ahead and installed a pre-charge relay and pre-charge resistor across the main contactors that essentially charges the bus capacitors up to pack voltage before closing the main contactor. Everything else is pretty much secured. I've also got the lid. Let's see here for a second. Also got the lid prepared. So this is the lid of the unit. It's made from I think 1.5mm aluminium. Down here we've installed the 23-pin Ampseal plug. We've got a loom coming off the back of that. That has all of the signal wiring, well basically signal and power wiring for the controller, and also got a tail here for the RS232, and that'll be so everything comes in and out of the controller via that 20-pin or 23-pin Ampseal plug. So not really a fan of them, these kind of weird connectors, because however it turns out for me, I always end up ordering the wrong plug for the wrong socket, but somehow with this managed to get it right the first time. This is the matching plug. Again, this is a the 23-pin Ampseal as employed on the DMOC 645, which is where this heatsink comes from. Now, I've been asked in a previous video why I was using a DMOC heatsink. Well, because they were cheap. These DMOC heatsinks, I think they might even still be on eBay. I picked up two of these for $100 each, and considering the quality of the work that went into them, that's quite a steal, and it made a very nice base to build up the controller. And of course it's a liquid cooled heatsink with, I would say, 3/4 inch hose tails on the back for coolant. So plug, I have to do these inserting the pins thing. I have the pins, so I'm going to have to figure out how to put them into this, but when it does, it doesn't fall over. That's it, you're in. So that means that if I need to remove the controller for any purpose, it's a hell of a lot easier just to unplug that and to disconnect a few traction cables than to mess about doing what I had been doing previously with just wires coming in and out and I use some of that barrier strip, which is quite good, but I think I'm just trying to improve on the procedures here. So I'm going to go ahead and make up a few of these tails, put them in here, and we'll come back then, and I might just for the purposes of just show how to make one of these. It's not exactly brain surgery. So sit tight, we'll be back. Okay folks, we are back. We have got 3 of the main high voltage cables installed at this point. So what we're going to do now is just go through putting a crimp on the last one, which will be the B- cable, and we'll just run through that, and then some more. We'll get the harness in, and we'll get the cover on the controller, and that should be about us. That should be about us on this end of the project. So what you can see here is hopefully got some tails here just for connecting to the motor, and we have the 2 tails here for connecting to the traction system. Now, so what we're going to do is we're going to strip and crimp this end of the cable here. Now, when I first looked at this, when I was doing the 3 series, to get a hydraulic crimping tool to put these lugs onto this is a 70 square cable. It's just ridiculous. You're the guts of €1,000. But I happened to have a look on eBay and came up with this little guy. This is a YQK70 hydraulic crimping tool, and it's of Chinese manufacture, but this little thing has done an amazing amount of work and makes a very good crimp indeed. This particular one goes from I think 8 square up to 70 square. I think you can actually get them go up to 240 square in this particular range. But this tool, I believe I got at the time for something like 60 or 70 euros, including delivery. And my take on it at the time was that, well, if it does the crimps on the 3 series and falls apart, I'll be perfectly happy with that. But it certainly has surpassed all of those expectations, and it's still going strong. It's quite a heavy, sturdy tool. So certainly for doing these crimps on high power systems, hitting it a few belts of a hammer for the sake of saving a small amount of money is probably going to burn the damn thing up. So get yourself one of these guys. Now the one caveat about it is that, for example, here I'm doing 70 square crimps with this tool, but I have put the 50 square die in there. It just makes a better bite on the lug, so that's the only caveat about using that tool. So next up we want to apply the crimp. Now this particular type of crimp, this is a short tube crimp that I have for doing these terminals coming off the IGBTs because it lets me get a nice tight radius on the cable, so that's why I chose those ones. So what we need to do next is we need to strip back some of the insulation. So what you want to do is take your crimp, hold it beside the cable, and that gives you a rough idea of how much insulation that you need to take back. And the best tool by far and away to do that is a pair of scissors. And you don't try to be a hero, just literally just work the scissors nice and gently around the thing. Just taking a little bite, and you'll feel it start to cut through the insulation. Get to that stage, just start to bend it over like that, and you're done. Next stage then, to put the actual crimp tag on. These have a kind of a bellows on them, which are a bell shape, I should say, on them, which makes it very handy. Get it on like so. Take something heavy like this shears, give it a few good belts. That just helps to spread the conductors out through the little window here. That tells you that the cable is in far enough. Get your crimping tool on. It's kind of handy having a bit of a belly here because I can support the crimping tool with it. Having said that, my belly has been shrinking at an alarming rate of recent vintage since taking up a new job, so but trying all the things to get it back, having an unbalanced, unhealthy diet and not getting enough exercise and watching too much TV, but it just won't come back. So I think it's gone. Anyway, once we have said crimped, what we need to do then is just to protect it from short circuits or from weather. So use a bit of heat shrink sleeving and proceed for that. It's again very simple. Just get enough of it to cover the crimp and a little bit of the cable. Cut it off. Stuff it over the damn thing. Just get it so that it's just thereabouts at that location there, and get your heat gun moving. And you're done. So this is the B- cable. So we're going to, let me see, yeah, and thread that through this gland here. The epoxy situation seems to be holding up, so hopefully it'll stand the test of time. I guess, knowing my luck, first time I take the car out there I'll probably crack away from the damn thing, but anyway, had to try. So no way to know otherwise. So I'm going to just twist the cable around a bit so we get the lug oriented in the way I want it. And we're going to do then, we have our bolt, it goes through the lug and down into number 3 IGBT. Which terminal is this? This would be the this would be the E2 terminal of the IGBTs, which is emitter 2, which is the bottom of the switch, which is our battery negative. So it's a bit of twisting and turning now to make this happen. This is where this flexible cable really comes into its own, and you can do a very tight radius when so required. There we go. Unfortunately, of course, to get a hex key in onto that now, just to get the thing started. We'll have to turn it around a little bit. So This is just the final stage of the controller build really now. And we'll be looking at the physical aspects of mounting it in the car over the next video or two, and that'll be based around securing it onto the motor brackets and so on. So the other gland here that we have, purpose of that, I won't be fitting a cable to that gland today, but the purpose will be that it will allow me to take a cable from the controller side of the main contactor, and that'll be a small cable, like a 16 square or something like that, and the purpose of that will be to allow me to run things that need pack voltage, things like the air conditioning, the heater, possibly a DC-DC converter, and whatever else things that need actual pack voltage, because obviously when the ignition is turned off, these contactors open and shut off all of the high voltage, so I'll only want to be tapping in after those contactors. So I'm going to go ahead and finish putting this cable in, and then we'll get the lid and we'll just do a final few minutes of footage there, just putting the top on the thing, and that'll be us. Back soon. Okay, so that's it. Big box. Got the harnesses hooked in, and just literally just sat the cover on, and just tried fitting some of the screws. Unlike the original DMOC setup, I won't be going for about 200 screws on each side of it, probably for IP68 or something like that. We've no need for that, fortunately. So hopefully now it'll just open up for me. There we go. So that's the internals. We've got the loom hooked in here to the terminal blocks on this end. We've all the high voltage cabling in, as I say, apart from this one, which will come at a later stage when I'm doing the heating, aircon and all that kind of thing. The harness is in, Ampseal is in, so I'll just grab the camera there and do a little bit of a close-up on this. So what we have is, we have our traction cables in, going through the glands, so hopefully those glands now will hold out. For this side we have the two Tyco Kilovac main contactors, copper bus bars and brass bolts holding on the cable with Nord locks. Over here we have the pre-charging circuit, control board, 15 volt DC-DC, current sensor, connection blocks, and that's our ignition warning light relay. And inside the box, as you can see, we have the loom going to the Ampseal for the signalling and power, and in there we have the RS232 header plug. So that is pretty much the controller as it stands. So the next stage in the plan with this guy will be to pretty much get it into the car. So sore ankle. So that's about where we're going to be, guys. So you can set the lid back up there now. First time doing this on camera, so it's bound to be a disaster. Just got to get the loom in here under the edge. There we go. We'll just check the other side of it. Yeah, it looks pretty good. Might as well screw it down. As I say, I just decided to go with 4 screws along the edge. I think they're M3.5, the original holes in the D-Mock, but I just drilled them out, and I just drilled out 4 of them and tapped them to M4 because it's kind of what I have to hand here. So we're just using some ordinary machine screws. Well, this should also, the fact that the controller is encased, should help with some of the EMI stuff, not that we're that too concerned about it. Certainly won't be looking at any form of EMC testing for this car. Though I'm sure that I know there are some countries in Europe that's I think it's used as a convenient means of making EVs pretty much impossible to do by oneself. So that is pretty much the conclusion. Hopefully it doesn't blow up, and if it does we'll rebuild it because we have the technology. So that's it, guys. Controller is done. Got to get it in the car and get ourselves that bit closer to the first voyage. So, thanks for staying with me and so forth. And we'll be back soon.